Now we need to solve this inequality by reading the graph. We want 2x minus, or 2/3 x minus 4 to be greater than 0. This is the line right here of y equals 2/3 x minus 4. Y-intercept was -4 up 2 and over 3 up 2 and over 3. Well, when is this greater than 0? Well, it's greater than 0 when x is here. That's when this line is greater than 0. So it's greater than 0 when x is greater than 6. And this is the solution. Here we want 2x minus 4 to be greater than or equal to 0. Here's the graph of 2x minus 4. Here's my 2. When is it greater than or equal to 0? Well, the line is above 0 here. So it's when x is greater than or equal to 2. Now in this case, we have two algebraic expressions with an inequality sign. 3x minus 2 is less than or equal to negative x minus 6. Well, this blue line is 3x minus 2, and the green line is negative x minus 6. They cross here at -1, -5. And we want the blue line to be less than or equal to the green line. When is the blue line less than or equal to the green line? And we separate this left to right. This is where it's less than. So that happens when x is less than or equal to this x value, -1. Compound inequalities. A compound inequality is a statement containing two simple inequalities connected by an and or an or statement. The solution to a compound inequality can be an interval of real numbers that does not involve infinity. It could be just bounded, an interval between two numbers. Because a bounded interval contains both of its endpoints, if it contains both of its endpoints, it can be closed. To the solution set for compound inequality using the connector OR is the union of two sets, and we just combine and put them together. The solution to a compound inequality that uses AND is the intersection of the two sets and is where they overlap. Now when we have bounded intervals, notice that the x is between the a and b and that all of these are less than or equal. If it's a is less than x is less than b, we have parentheses with both the a and the b. When we graph it, it's parentheses at both the a and the b shaded in between. If it's a less than or equal to x, less than or equal to b, this or equal, it makes it brackets. This is closed. When we graph it on the number line, again brackets at a and b shaded in between. Or we can have half of each. A is less than or equal to x is less than b, so bracket and parentheses, or a is less than x is less than or equal to b, parentheses and bracket. Also the same on the number lines. Here we want to write this each interval. It might help us to do a quick number line. So here's a number line, 0 and 6. We want from -infinity to 0 would be this, and then from -infinity 6 would be this. This is a union, so we want them just combined. So anywhere that's shaded would be this part, and we go from -infinity to 6. These are ORs. the word or. With a union, it's the or. So on the number line, there's 3, 5, and 7, bracket it between with 3 and 5, and a bracket with 5 and 7, shaded in between, they overlap, so what's in one or the other would be from 3 to 7, both with brackets. These are intersections. We need to know where they overlap. In this one quickly, 3, 4, and 7. We have parentheses, 3 to 7, parentheses, 3 to infinity. Where do they overlap? Just this part, from 4 to 7, with parentheses, because 4 and 7 were with parentheses. From negative 3 to infinity, intersected with 2 to infinity. If we draw a quick graph, that helps me the most to picture it. Negative 3 to infinity would be here. 2 to infinity would be here. They only overlap from this on, so that would be 2 to infinity. Solve this and give it the answer in interval notation. Notice we do have, like we did with our examples of bounded intervals, we have the x in the middle. So we treat this as if it had 3 sides. We add an 8 to each side. 9 is less than or equal to 6x is less than or equal to 12. We divide by 6. 3 halves is less than or equal to x is less than or equal to 2. Interval notation, we have brackets because they're or equal. 3 halves to 2. Graphing it, divided 0, 1, 2, and 3. 3 halves would be halfway in between, and 2 be this part. 3 halves to 2. In this one, we really have 2 separate inequalities that are connected with this and, which of course is an intersection. Solving each one separately, negative x is less than negative 1, so x is greater than 1. Here we have 2/10 x will be less than 6 when we add 5 to each side. When we divide by 2/10, which would be 1/5, we'll find out that x is less than 30. Now we need the overlap from being x greater than 1, x less than 30. In interval notation, that would be from 1 to 30. Graphing it of 1, 30. They're less than and greater than only, so we'll have parentheses and shaded in between.